This is Sharma solution class 12 chapter 7 adjoint and inverse of a matrix. We are taking the multiple choice question, that is MCQs. Now here we have a raised 5 is equal to 0, and you can call it as a null matrix also given as a raised n is not equal to I. Then there is a range of n from 1 to 4. So I minus a inverse, what will be the value of that? Before we go ahead, let me tell you, a raised 5 minus b raised 5 is a minus b, along with the term where we have a and b combination. Okay, so in place of a we are putting I, in place of b we are putting a. Why we are doing this? Because I raised 5 minus a raised 5, we'll use this formula. I square, I cube, I raised 4, I raised to the power n. It will always be I only. Or if you multiply by anything, that thing will come. So I minus a, wherever you have b, just put a, and wherever you see a, just put I. But wherever their combination is there, just put a. So I plus a square plus a cube plus a raised 4. Right? Now, a raised 5, it is equal to null. It is given in the question. So we can just write I raised 5. I to the power n will always be I. So right hand side I am taking in the denominator I minus a. Now right hand side. Now I just assume it to be 1. It's actually 1 in matrix form. So 1 by I minus a can be written as I minus a inverse, and that is going to be equal to what? I plus a square plus a cube plus a raised 4. Okay. Now this whole is nowhere to be found, so the answer is none of these. Next one is, if a satisfies the equation, this one, because a is satisfying this equation, then a inverse exists if. So we'll put a in this equation because it is satisfying. Then we'll try to find out a inverse, and then we'll see what condition it should exist. So the answer is lambda is not equal to 0. You'll just see how this comes. First, we will satisfy this a with this equation. You have a cube minus 5 into a square plus 4 into a, and lambda I am taking on the right hand side. So it is negative lambda. Now this thing you have to do for many of the questions. Whenever this type of question comes, multiply both sides by a inverse. So because we have to find out a inverse, so in order to introduce also, just multiply both sides by a inverse. You can do a inverse into this, so whenever you multiply a inverse, it should be on either left hand side or right hand side of that numeral or expression. So whenever we multiply a inverse with say a cube or a square, one power will be deducted. So it will be a square. Here 5a plus 4a into a inverse is I. So you may write 4i, or you may just go on with 4. Okay. So this is minus a inverse lambda. Okay. So what we are interested in? A inverse. So lambda I am taking in the denominator, and there is a negative also. So this is lambda. Negative I am saying. So let us write it in negative. A square minus 5a plus 4 and divided by lambda. Now when we have a by b condition, that is only possible when b is not equal to 0. Otherwise that division will be not defined. So lambda cannot be 0. A inverse only exists when lambda is not there, or lambda is not 0. Lambda should not be equal to 0. Okay. So lambda not equal to 0 is the answer. If for the matrix a cube equals I, then a inverse. Now this is very straightforward question. Just multiply both sides by a inverse. Whenever you have a inverse, introduce it yourself. So just multiply a inverse. A inverse with a cube will be a square. anything multiplied by identity will be that thing only. So A inverse equals A square. So this is the answer. First one is the answer. If A and B are square matrices such that, now square matrices and such that B equals negative A inverse B A. So A plus B square we have to find out. And please remember, it is not that A plus B whole square, so that you get A square plus B square plus 2AB. No, that's incorrect. This is a matrix. So AB and BA, they are not same. Okay, it's not commutative. Matrix multiplication is not commutative. So what we have to do here is, as I said, B is equal to this. Now let us multiply both sides by A. Why? Because we just want to get rid of this A inverse. So multiply this A on both sides, here also A. Now AB equals A inverse is identity. So B into A. Now AB is equal to minus B. We'll use it, we'll employ it, right? When we multiply A and A inverse, we get identity. That also you should know. Let us now turn to A plus B whole square. This is going to be A square plus B square plus AB plus BA. Now AB minus B is equal to minus BA. So this is minus BA. You can cancel these two out. It will be A squared plus B square, and that is your answer here. Second option is your correct answer. Now if A is equal to this, then A raised 5. A raised 5. This is a scalar matrix. So this is A. Let me write it like this. A. I am taking 2 outside for a time being. So inside we'll get the identity matrix 1 0 0 0 1 0 0 0 1. So we can write it as A equals 2I. A raised 5 is, take the power of 5 both sides. So A raised 5 will be equal to 2 raised 5. 2 to the power 4 I am taking here. 1 2 I am keeping it with I. 2 to the power 4 is 16 and 2I. Now this 2I is what? You see A. 2I is A only. We have already seen this A is what? 2 into I only. So A raised 5 is 16. This is your 2 0 0 0 2 0 0 0 2, and that is nothing but your, it was A. It is A. So A raised 5 is equal to 16 into A. That is your answer. For non-singular square matrix A, B, C of the same order, A, B inverse C need to be found out. Always remember, we have already seen that A, B inverse is equal to B inverse into A inverse. Now we have 3 matrix here. When we take the inverse, we will start with C, C inverse, then the B, B inverse of inverse, and then A inverse. Inverse of inverse is that same matrix. So C inverse, B, A inverse. What is this one? Fourth one is the correct option. The matrix, this one, is a singular matrix. The value of B is, what is the value of B? Now singular matrix is that matrix determinant value is equal to 0. So we have to find out the determinant. I hope you'll be able to find out the determinant. I'll just show you what you'll get when you open with 5 and 3. But here 20b is cancelled. So you get 60 minus 12. That is 48 equals 0, which is, this is not what we wanted. So B is not existent. There's no B. This is because of this situation. If D is the determinant of square matrix A of order n, then the determinant of its adjoint is, okay, see. So we will use that expression. We have generally seen this in our properties session, but adjoint of A determinant is nothing but determinant of A raised to the power n minus 1. Now determinant of A is what? Determinant of A is D. So I am writing D here. N minus 1 raised to the power n minus 1. This is the answer. If A is a matrix of order 3 and determinant of A is 8, then the adjoint A determinant. Just seen this question already. Adjoint of A will be equal to determinant of A raised to the power n minus 1. Determinant of A is what? It's 8. What is n? It's 3. 3 minus 1 is 2. So it's 2, but there is no answer like that. So let me write this 8 as 2 cube. 2 cube is 8. We don't have any answer like that, so we have to convert it in the form of 2. So 3 to the power 3 to the power 2 is 2 to the power 6. Okay, this kind of question, the only way is to multiply it by A inverse. Because the question is asking about the inverse of A when this expression is given. So the best way is to multiply both sides by A inverse. Let me do it. A square minus A plus I is equal to, this is null matrix, it is not 0. And let us multiply this with A inverse on both the sides. A inverse, A square is A inverse A is identity element here. You get I plus A inverse I will be again A inverse equals A inverse into null matrix will again be 0 only. So A minus I, you can take A inverse I on one side. So the other side will have this I minus A. So this will be I minus A. Simply A inverse is I minus A. This is what you see in the lower part of this screen. You see A inverse equal to I minus A. I have just made it as A inverse equals to A minus I. I'll just change it because A, as we have taken this on right hand side, A inverse I will be equal to I minus A. So this is the correct answer. Third one is your correct option. If A and B are invertible matrices, which of the following statement is not correct? This kind of question we have already taken in the initial questions of this exercise. So let me just tell you, A plus B inverse is equal to A inverse plus B inverse is definitely not correct. This we have already seen. I requested you also to solve that question by yourself, because other are the properties. Other these A B inverse equal B inverse A inverse, we have just done. We have just completed one question like that. So the correct answer is third one. If A is a square matrix such that A square equals I, then A inverse is equal to, this is very straightforward, multiply both sides by A inverse. A square equals I, multiply this by A inverse. A inverse here, A inverse here. A inverse A square will be A, and A equals A inverse. This is your answer. So second is your correct option. A is this, B is this, and X be a matrix such that A equals Bx, then X is equal to. So I'll show you to you here only. So what will be the first answer is the first one. This is the solution. But how did it came? How did it come? Sorry. So A equals Bx. Now multiply both sides by B inverse. What do you get? B inverse B is I. B inverse A equals I into X. I into X is X only. So X equals B inverse A. So we have to find out the inverse of B. So what will be the inverse? First we'll find out the adjoint. 2 and 1 I am replacing. 0, 0 will be negative 0. So it will be 0 only. This is the adjoint. What is the determinant? 2 minus 0. So divided by 2. So this is going to be B inverse. Now this whole has to be multiplied by A. This whole is your B inverse, and this multiplication will give you this result. Calculation, I think you will be able to do it. If A is this matrix 2, 3, 5 minus 2, be such that A inverse is equal to K into A, then what will be K? So this is quite straightforward. I'll just do it here. A inverse we can compute. It's quite easy because this is 2 by 2 matrix. A inverse we'll find out, and then we'll try to equate it with K, and we'll see what K comes, because there will be definitely A coming on the right hand side. If you remember, this question is already being done. So A is 2, 3, 5 and minus 2. And what is the adjoint? Adjoint is exchange this values, diagonal value, so it will be negative 2, 2. Change the sign of 5 and 3, it will be minus 5, minus 3. Now, when we have done this, this is the determinant is minus 2 to the 4, minus 5 to the 15. So determinant is minus 19. So you can just divide this by minus 1 by minus 19, or you can say minus 1 by 19 is multiplied. This is your A inverse. Now let us equate this with A inverse equals K, because question is giving. Question is saying that A inverse is equal to K. Now I'm taking negative outside from this matrix, or you can say multiplying negative inside. So it will be plus 1 by 19. So now I'm equating, what is this? 2, 3, 5 minus 2. This is your original matrix, it is A. So A inverse equals 1 by 19A. So what is question saying? A inverse equals KA. By these two, K is equal to 1 by 19. This is your answer.